Welcome to 8.4, testing the difference between proportions. This is a two-sample z-test for the difference between proportions. So what if you're given a population proportion, meaning you're given p instead? Possible pairs of the null and our alternative could look something like this. Or this. Or lastly, it could be this. But we would be comparing the two population proportions in some way. So again, once you find p, you can find q because q is going to be 1 minus p. The conditions for this is that it must be random, it must be independent, and we must have each of these being greater than or equal to 5. Since we have two samples, you have 4 things to test instead of just 1. Make sure that you test, because if you can't use them, you will do all that work for nothing. So your equations are here, where your test stat is p1 hat minus p2 hat. Your z is p1 hat minus p2 hat minus the difference between the proportions, which, like the others, we're assuming this part is 0, over the square root of p bar times q bar 1 over n1 plus 1 over n2. P bar can be calculated as x1 plus x2 over n1 plus n2, and q bar is going to be 1 minus p bar. Remember that n1 times p1, n1 times q1, n2 times p2, and n2 times q2 all have to be bigger than or equal to 5 for you to even look at these. Also notice that we're using the z, so you're going to be using the z chart. So let's try one. A study of 150 randomly selected occupants in passenger cars and 200 in pickup trucks shows that 86% in the passenger cars and 74% in the pickup trucks wear seatbelts. So you already see we have two different things. We have the passenger cars of 150 with a percentage of 0.86. Okay, and then we have the pickup trucks. We surveyed 200 of those with a percentage of 0.74 or 74%. At a level of significance of 0.10, can you reject the claim that the proportion of occupants who wear seatbelts is the same for the passenger cars and pickup trucks? Okay, so the next thing we need is our x1. Well, 86% of 150 will give me my x1, and 86% of 150 is 129. x2 would be 74% of 200, which would be 148. The claim is that it's the same. So h sub o would be p1 is equal to p2. That's my claim. So looking at this, I know it's two-tailed. I'm looking at the z chart. If it's two-tailed and my level of significance is 0.1, I need 1/2 0.1. And I'm looking at my chart. I see that's negative 1.645 and 1.645. Now I can plug my information into my equation. So I need my p bar first. That would be x1 plus x2 divided by n1 plus n2 which means my Q bar is 1 minus and then we can go to our Z equation to plug everything in. So my Z equation would be P1 hat minus P2 hat minus the difference, we're assuming there is no difference, so it would be 0, over the square root of P bar times Q bar times 1 over N1 plus 1 over N2. Okay. Gives me about 3. So that does put me in the rejection region. So I reject H sub O and at a level of significance of 0.1 or 10% do not support the claim because I just threw it out. Oops. Okay, let's try another one. This one says a medical research team conducted a study to test the effect of cholesterol-reducing medication. At the end of the study, the researchers found that 4,700 randomly selected subjects who took the medication, 301 died of heart disease. Of the 4,300 randomly selected who took the placebo, 357 died of heart disease. So we can write this out. Our N1 is 4,700. With an x1 of 301. So a little bit different. This one gives you n1 and x1. You'll have to find the percentage. That would be x1 over 4,700. And then our second group who took the placebo, that was 4,300. We had 357 die. So we'll find our percentage, that would be 0.083. We want our level of significance at 0.01. Can you support the claim that the death rate due to heart disease is lower? So this was due to heart disease. So H sub O, be here, H sub A, means that it's lower. This would be my claim. Therefore, it is left-tailed, because it's pointing to the left. So I'd look at this in the back of the book to find my Z is negative 2.33. Start by finding your P bar, x1 plus x2 divided by n1 plus n2. Which means our Q bar is 1 minus 0.07. Okay, so plug into our Z. P hat, or P1 hat, minus P2 hat, minus the difference we're assuming is 0, over the square root, 0.07, times 0.93 times 1 over 4,700 plus 1 over 4,300. So now we'll take it to our calculators. Okay, we get negative 3.8. That is in the rejection region. So I would reject H sub O. So since I throw out H sub O and H sub A is the only thing that's left, I would say at 1%, that's my level of significance, I am supporting the claim. All right, so we will start this assignment together in Zoom tomorrow.